In this lesson, we shall focus on mathematics, trigonometry, grade 11, grade 12, and we shall look at wide range of applications that pertain trigonometry. And we proceed as follows. Right, first and foremost, we shall be solving sides, but also angles. Right, in triangles that are not right-angled triangles, sine, cosine, and area rule. The rules are the sine rule, the cosine rule, and the area rule. So we shall be studying these three rules here. Right, the formula is the sine A over A equals sine B over B, sine C over C. Another formula is C squared equals A squared plus B squared minus 2AB cosine C. And the area formula is half AB sine C. When to use these rules? Given two sides and the angle opposite one of the two sides. Right, so in other words, when you're given two sides and the angle opposite one of the two sides. Given one side and any two angles. Right, so in other words, to use the sine rule, you need to be given two sides. So you can be given like side A and side B, and one angle opposite one of the sides. So if you're given side A, side B, and also angle B, you can be able to find, for example, angle A. Or you're given one side and two angles. So you can be given like two angles A and B, and you're given, for instance, a side B, and also you're not given side A, for example. So you can be able to do this. Given two sides and then and the included angle. Sorry. Now, if you're given two sides and the included angle, you can use the cosine rule. Or also, if you're given all three sides of a given triangle, all three sides given, the cosine rule becomes applicable. Now, the area, whenever area is required, you need to find the area. You use area rule. In order to use the formula for area, you must be given two sides and the included angle. Right. So in other words, two sides and the included angle are required for the area. Okay, we proceed. Right, here is a past examination question that seeks to apply the rules we've learned thus far. Right, in the diagram, A, B, and C are points in the same horizontal plane. A, B, and C are points in the same horizontal plane. D is a point directly above C. Yes, actually C and D is a point directly above. That is, DC is perpendicular to AC. DC is perpendicular to AC. Oh, we can see here is A and there is C, and DC is perpendicular, making an angle of 90 degrees. And DC is perpendicular to BC. Here it's BC, and you can see this is perpendicular to BC. It is given that ACB is 100 degrees. ACB is 100 degrees. CAD is 30 degrees. CAD is 30 degrees. Now, AD is 20 units. AD is 20 units, and BC is 8 units. BC is 8 units. Now, calculate the length of AC. Right, calculate the length of AC. So this is A, and that is C, and we need the length. So this is adjacent over hypotenuse. Cosine of 30. Right, so obviously now you can actually be in a position to use that. But now, as we're going to do question 7.1.1, this one here, want to find AC. So it is always best to say in triangle, state the triangle to the examiner. So we're going to work in triangle DAC. Right, in triangle DAC. Right, in the triangle DAC, we have the cosine. Right, so the cosine of 30 degrees equals the adjacent side, AC over the hypotenuse, 20. We want AC, so that by cross multiplication, clearly AC becomes 20 cosine 30 degrees, which means AC equals what? We can be able to use our calculator here and get the answer as follows. Right, so now we're able to get the answer as follows. So we have with us now the calculator is actually in degrees, so all is well. 20 times cosine 30. Cosine 30 degrees, and the answer is what? The answer is 10, the square root of 3 units. And this is exactly the same as 17.32. 17.32 units, or 17.32 units is what we have. So in other words, we've seen that AC is 10. The square root of 3, 17.32 units. 17.32 units, like that. And that is exactly the length of AC. The length of AC. Where's the question? Who has a question here about the length of AC? Any question? So the length of AC is 10. The square root of 3 units. What is the length of AB? The length of AB. So at this point, we know that AC is 10. The square root of 3 units. We want to find the length of AB. Right, here it's A and here it's B. We want to find the length of AB, the distance from A to B. Who can find the length of AB? Pegalelo, what do you think?
So let me calculate real quickly.
Okay. AB. Want to find the length of AB. What rule would you use to find the length of AB? What rule? What rule would you use to find the length of AB? What rule would you use to find the length of AB? What rule would you use to find the length of AB? Right. So we're going to state, okay, now to find the length of AB, we can decide to work in this triangle here. So AB we can find by saying AB squared. But now first state the triangle. So you can say to the examiner in triangle. In triangle,
So are you using the cosine rule?
yes, well done. Using the cosine rule. We're using exactly the cosine rule. Right, so as we're using the cosine rule, what do we have? Right, we're using the cosine rule. And using the cosine rule, we have exactly AB squared equals. So if AB squared equals exactly AC squared plus BC squared. Right, so we have AB squared in the triangle ABC, in the triangle ABC. So we have AB squared equals AC squared plus BC squared minus 2AC. BC. Cosine. Cosine of the angle here and the angle there is the angle BCA. What is AB squared? Right, so we have AC. 10 the square root of 3, you square it. BC minus 2. What is AC? 10 the square root of 3. BC. BC. It's 8. Cosine of the angle BCA. 100 degrees. Right, and we use our calculator to get the result so that AB squared equals the following. Pay attention. Pay attention. So we're going to have exactly here 10 the square root of 3. 10 the square root of 3. You close the bracket, you square this. Plus 8 squared. Minus 2 times 10. The square root of 3 times 8 times cosine 100 degrees, close bracket, equals, right, we're getting exactly 412.12 units or square units. 412.12 square units because it is equal to AB squared. So we have 412.12. So we have actually 412.12 square units. And therefore, this means that if we have AB squared, you take the square root here, and you have the square root of 412.12. So that we have AB equals, right, we take the square root of 412.12. So we take the square root of the answer, and it becomes exactly 20.30. 20.30. So 20.30 units. Where's the question? Who has a question so far? Any question? Who does not understand and who is confused? Who does not understand and who is confused? Who has a question here so far? Any question? No question. In the absence of a question, we move forward. 7.2 is next. So we've seen that AB, now we've seen that AC is 10 to the square root of 3, AB is 20.30. 20.30. 10 to the square root of 3 units. Now we want to actually therefore calculate the size of ADB. ADB. This one here. Right, so to find the size of the angle ADB. So now if it is further given that ABD is 73. ABD is actually 73.4 degrees. Calculate the size of the angle ADB. So we need ADB like that. Right, so we're in a position to actually determine the size of the angle ADB. Right, and to find the size of the angle ADB, we use the trigonometric sine rule in triangle. In triangle ABD. In triangle ABD. So you have the following here. Right, so we want to find the size of the angle ADB, the size of this angle here. So we're going to say the sine. ADB. ADB divided by 20.30 is equal to the sine of 73.4 degrees divided by the angle opposite, 20. We cross multiply and we're able to see that the sine of ADB angle, cross multiply and you get 20.30. The sine of 73.4 degrees, all divided by 20, meaning the angle ADB is arc the trigonometric sine of 20.30. The sine of 73.4 divided by 20. Right, so you're going to use a calculator right now to find the size of the angle ADB. Right, and to find the size of the angle ADB, we proceed as follows. So now it is actually exactly shift sine of the rational expression 20.30 multiplied by the sine of 73.4 degrees over 20, close bracket like this, equals what? 76.58. 76.58. 76.58 degrees. So these are your 76.58 degrees. 76.58 degrees. Any question? Any question? Who has a question here so far? Who has a question here so far? Who is confused? Who is able to follow and who cannot follow? Right, in which case, therefore, we move forward. We cover more questions moving forward as follows. Right. Okay, now the next question is question 7 as shown here. Right, question 7 in the diagram. S, T, and K. S, T, and K lie in the same horizontal plane. So S, T, and K lie in the same horizontal plane. RS is the vertical tower. RS is the vertical tower. The angle of depression from R to K is beta. Here is the angle beta. Right, now the angle TSK is alpha. TSK, the angle is alpha. TS is P meters. TS is P meters. And the area of triangle STK is Q. The area of triangle STK is what? Is Q square meters. We are here to learn this section. Please, guys, it's very important for grade 11s. It's very important for the matrix. It is part of the curriculum. And therefore, you need to ensure that you pay particular attention and also you're able to understand when to use the rules. Determine the length of SK in terms of P, Q, and alpha. The length of SK. The question is, what is the length of SK? In terms of P, Q, and alpha, let us find the length of SK. What rule do we use to find the length of SK? In terms of P, Q, and alpha. Anyone home who knows what rule to use here? Who knows what rule to use here? Who knows what rule to use here? Right, any question? Any question? Right. Any question? Any idea? Right. So obviously we can see that to be able to find the length of SK in a way that in an expression that is going to involve Q, you need to use the area rule. Yeah, so you have the area. Area of triangle, STK. Now the area of triangle, STK, is half what? So it's going to be half the following. So it's going to be half TS SK, the sine of alpha. So the area of triangle STK is half TS SK sine alpha. What is the area of the triangle STK? Q. What is TS? P. Right, and then you have exactly SK times the sine of alpha. We cross multiply, we get 2Q. P times SK sine alpha. 2Q divided by P, the sine of alpha. SK equals 2Q divided by P sine alpha. This is SK in terms of P, Q, and alpha. Any question? Any question? Right, so Shelo, you need to note that we have our own registration. We have our own registration fee to be able to participate in this program. And the registration fee sits at 750 per month. Right, and it's 750 per month. And the 750 per month allows you to participate and have access to our online classes. Now there is a WhatsApp number. And the WhatsApp number is +27 82044 8712. It is through this WhatsApp number that you can be in a position to chat to us, and your parent, your guardian can assist you to register so that you can be able to take part in our mathematics and science lessons as we broadcast regularly. Okay, so this is something very important. So I know that sometimes I remind the students who are not aware that it's very important they register, because the students who are not registered, whose parents you do not talk to your parent, Shelo, you decide not to talk to your parent, or your parent does not know about the fact that there's extra maths, there's extra science that is intended to improve your grades. So now you keep quiet about it, and your parent doesn't know, and you are missing out on an excellent opportunity. Now, the students who are not registered will be given just limited time to take part in these discussions, and we shall obviously always, terminate their communication there during the course of the lesson. We have seen here that SK in the previous discussion is 2Q over P sine alpha. 2Q over P sine alpha. That is actually our SK expression. Now in 7.2, that is what we're doing next. We need to show that RS is equal to that. So RS. So to find RS in a way that is going to involve beta, we're going to decide to tell the examiner, Mr. Examiner, we're going to work in triangle. right, where we need the RS, but it's going to involve beta. Beta now is here, and beta is the angle of depression from R to K. The angle of depression from R to K is beta. Right, so here is the angle, which is beta here. Meaning that we can decide to make a triangle RSK so that we have the tangent of beta. Tangent of beta is opposite over what? Opposite over adjacent using SOHCAHTOA. Right, using SOHCAHTOA. So that the tangent of beta becomes exactly opposite over adjacent, and opposite here is exactly what? Is exactly RS over adjacent. Adjacent is exactly SK. We cross multiply and we're able to see that, okay, RS is actually SK, the tangent of beta. SK, the tangent of beta. So that now we're able to see that, okay, the side RS in this case is equal to what is SK? Right, in the place of SK here, we put 2Q over P sine alpha. The tangent of beta, which is that the tangent of beta over P sine alpha. And these are as proven 7.2 for the 2 marks there. So our S is 2Q tan beta divided by P sine alpha. So that is very important for us to take into account and to consider, but very, very seriously. Very, very seriously. So this is it. This is it. Right. So any questions so far for the 2 marks? Any questions so far for the 2 marks? Any questions so far for the 2 marks? Right. So in the absence of a question, we move forward. In the absence of a question, we move forward. Right. We move forward to 7.3. Calculate the size of alpha. Here is the angle alpha. We need to find the size of alpha. If the angle alpha is smaller than 90 degrees, meaning it's an acute angle, but RS is 70. P is 80 meters. Q is 2,500 square meters. RS. 2Q tan beta divided by P sine alpha. What is our Q? Our Q is actually exactly using this formula where RS is 2Q, tangent of beta, divided by P sine alpha. We have that Q is 2,500. The tangent of beta, beta is 42 degrees. P is 80. The sine of alpha, and alpha is what? Alpha is, okay, now you need to calculate the size of alpha. You need to calculate the size of alpha. Okay. So we can write it a little bit at the bottom here for clarity. Right, let's write it at the bottom and say, what is RS? RS is 70. You're going to put 70 equals to the Q is 2,500. The tangent of 42 degrees. P, 80, the sine of alpha. Okay, we're good. What is sine alpha? Okay, so what is 2 times 2,500? It's actually 5,000. The tangent of 42 degrees, right? So you actually make the sine alpha the subject. And so now you're going to have in the bottom here 80 times 70, which means that alpha is arc sine 5,042. Eighty by 70. What is alpha? Okay, use a calculator. Let's use a calculator to do this one. Using a calculator, we have the following. We have arc sine 5,000 times 1042. 80 times 70. You close. Equals. This means that the alpha is 53.51 degrees. 53.51 degrees rounded off to 2 decimal places. 53.51 degrees. And this becomes the answer. Checking that again. It is 53.51 degrees. 53.51 degrees is actually the required angle alpha there. Where's the question? Who has a question? Right, so in the absence of a question, we move on. We move forward. In the absence of a question, we move forward. Right. So very interesting. And we remind Hlelo, right, Hlelo, that there is something we call the registration. We call it the registration fee of 750 Rand per month. And this means two lessons per week. This means you have access to 2 lessons every week. And you can be in a position to learn a lot of the mathematics, a lot of the science. So now it's 750 per month. And it is per subject. So you choose whether you want to do maths, or you want to do science. Right, you choose whether you want to do maths or science or both. Okay, so you can do math or science or both. Right, you can do both. You can do both. Obviously, but one subject is 750 Rand per month. You have 2 lessons every week, in which case, therefore, we shall be having even more frequent lessons during the course of the week. But the weekend becomes an opportune moment to cover more lessons in the evenings at 8 p.m. Right, and we believe that at 8 p.m., that's when most of the students are a little bit free to participate in these online classes, and we move forward. We move forward. So now it means, therefore, we've given Hlelo nearly 38 minutes of free time. Now the time is 38. So we've given Hlelo 38 minutes of a free lesson because your mom did not speak to me yet. Neither your father has not spoken to me yet. So you need to tell your mom, you need to tell your father to contact us on the WhatsApp. You need to tell your mother or your father to contact us on the WhatsApp. 27 + 27 82044 8712. You can write here plus 2782044871. So your mom or your father, your guardian, can speak to us about registering for you so that you can be actually officially entitled to have access to our platform, and you can be able to join the lessons every time. Because I know that today you joined. I know, Shell, already you joined last time, and therefore it is exciting that you have joined. But yeah, your time finishes now. If your mom registers for you or your father registers for you, you will have the opportunity to attend a lot more. Right? You'll have the opportunity to attend a lot more. And we move to the next question as follows. Right. So now, Shelo's time has expired. We love Shelo so much. Right, we love Shelo so much, but I know that your mom is not registered for you yet, Shelo. Right, because your mom is not registered for you. Please tell them to register for you because your time is up. We just gave you like 38 minutes to get a sense of what it means to learn online. But once your mom registers for you, or your father registers for you, or your uncle registers for you, you'll have the opportunity to attend a lot more. Okay, right. So that is, I'm sure, very clear to Shelo there. Right. So we continue. Right. We continue. Right. Now we're looking at question 7. AB is the vertical flagpole. Right. And this vertical flagpole that is actually the square root of 5 meters long. And we can see the vertical flagpole of that length. AC and AD are 2 cables. Check. AC and AD are 2 cables anchoring the flagpole. B, C, and D are in the same horizontal plane. B, C, and D are in the same horizontal plane. BD is 2p meters. BD is 2p meters. ACD is X. ACD is X. ADC is 45 degrees. ADC is 45 degrees. Determine the length of AD in terms of P. Want to determine the length of AD in terms of P. Want to find the length here of AD in terms of P. And to do that, you're going to decide to work in triangle. Right, like this in the exam. We're going to work in triangle ABD. Triangle ABD. So in the triangle ABD, we're going to use the Pythagoras theorem, because this is right angled. It's a right angled triangle. This right angled triangle, we can be able to find the AD. So we're going to say AD squared. Right. AD squared is equal to the square root of 5p squared plus 2p squared. So this is it. This is it. So the square on the hypotenuse is the sum of the squares on the other two sides. So that we have AD squared equals, what is the square root of 5 if we square it? We have 5p squared plus, if you square the 2, you get 4p squared. Meaning if you have AD squared equals 5 plus 4 is 9p squared, so that we have AD squared equals 9p, right, 9p squared, and you apply the square root here, you apply the square root there, so that in the end we have actually exactly AB equals the square root of 9 is 3 p there, and this is meters. So we have been able to find the length of AD in terms of P. We have been able to find the length of AD in terms of P. Right, so what is AD? So AD, therefore, is 3p meters. AD is 3p meters. Where's the question? We have a question, Peralelo. No question. In the absence of a question,
Any question, sir?
okay, fine, thanks. We move on to the next question. And You have the opportunity to participate, to ask questions, to engage a little bit more. Okay, we move forward. And in moving forward, we try question 7.2. All right, this one you already know is 3p. We've already got that one. And right now we have the following there. Right, want to show that the length of CD is equal to this. Now, here it's C and there it's D, and we'll say what is the length of CD there, and that is what we want, right? And so to be able to find the length of CD, the couple of things we need to take into account, right? So to find the length of CD, we need to be able to compute the length of CD accordingly using any of the rules that we know, right? We already know that this one is X. This one is 45, which means that this angle here is going to be the same as 180 degrees minus X minus 45 degrees. Meaning, therefore, you have 180 minus 45, which is 135 degrees minus X. Minus X. So that then in the end, we have the following here. Right. So if we want to find the CD, we're going to then say in triangle. Always say the triangle in which you're going to work, actually be working. So in triangle CAD. Right. Then you're going to say exactly CD divided by the sine of 135 minus X. So CD over the side of 135 minus X is equal to what? CD over the sine of 135 minus X is equal to what? So you can use here, there's a 3p that is already visible here, and you can use that. So you can say we took the one to find CD by the sine rule, so we can say it is equal to 3p over the sine of the angle opposite, which is the sine of X. Like so. We cross multiply this, getting exactly CD equals. Right, it is actually 3p, the sine of 135 degrees minus X, and this is divided by the sine of X, like so. Getting CD equals what? 3p. Okay, now, this is what we use. There's a formula we use here when we then say the sine of A minus B, it's called a compound angle formula, is actually the sine of A cosine B minus cosine A sine B. So that this is the sine of 135 degrees cosine X cosine of 135 degrees, the sine of X divided by the sine of X. So that in the end, we have the following. CD equals, then we have actually 3p. 135 degrees is the same as what? 135 degrees is the same as 180 degrees minus 45 degrees. Cosine X. The cosine of 180 degrees minus 45 degrees. Sine X. All divided by sine X. Meaning CD is equal to 3p. Right, in each quadrant is 180 degrees minus. It is in the second quadrant where the sign is positive, and this gives us the sine of 45 degrees. Cosine X. 180 degrees minus 45 gives us an angle in the second quadrant where the cosine is negative, but there's another negative which is going to be plus. cosine of 45 degrees, the sine of x, all divided by the sine of x, like so. Meaning at this point, we actually have been in a position to obtain the following. So we have, therefore, that CD equals, right, CD equals, you can write it at the top here. So we know, therefore, that CD is equal to 3P, right? What is the sine of 45 degrees? So we can be able to draw the special triangle of 45 degrees. The special triangle of 45 degrees, if this angle is 45 degrees there, the square root of 2, 1, and 1, you would then say the sine of 45 degrees becomes what? Then we're going to use soccer tower. The side is opposite of hypotenuse. Opposite of hypotenuse. Which means it is 1 over the square root of 2 cosine x. 1 over the square root of 2 sine x. All over sine x, which is CD. Therefore, now you have this, and the square root of 2 is at the bottom, so you can actually bring it to the bottom. So this is actually exactly the same as you can take out a common factor of 1 over the square root of 2, so that it's going to be somewhere there. And you have, and you can actually manipulate the terms. That's fine. You can write like that. So you have cosine x plus the sine of x all over sine x. Right, meaning at this point, what we're able to see is, therefore, that the CD can be written as 3P. Right, we start with the sine x, cosine x divided by the square root of 2 sine x, which is exactly this here. Which is exactly that. So these are the things you need to learn. And this is credit to what you call the compound angle formula we used. The sine of A minus B is the sine of A cosine B minus cosine A, the sine of B. This is called the compound. It's called the compound angle formula. Compound angle formula. So any question here? Right, in the absence of a question, we move to the next point. Next question. 7.3. 7.3. If it is further given that P is equal to 10, X is 110 degrees, calculate the area of triangle ADC. ADC. Right, so you need the area of the triangle ADC. We've already been told that X is 110 degrees. And this one is 45. So you see, you have 110 degrees plus 45 degrees, which is 155. 155. So if it's 155 degrees, then you can be in a position to compute the area of the triangle ADC. All right. So obviously, there are certain things you already know. This one you know is 3P, and this CD is exactly this one here. Then, so to be in a position to compute the area, all right, you already know the angle ADC is 45 degrees. Right, so that in the end, then we can be able to deal with the DC. What is actually CD? So the CD can be found as follows. You say 3 times P. P is 10. Right, and you have the sine of 110 degrees, cosine of 110 degrees. The square root of 2, the sine of 110 degrees. So, right, we have the following. 3 times 10. And then you have the sine. One 10. 110. Two times the sine 110, which is actually 13.49. 13.49. So this one is going to be actually 13.49. Right, so 13.49 meters. Right, so if the CD is actually 13.49 meters, right, then we can be able to find, and this one is 3p, p is 10. So this is actually 30. So that now the area of triangle ADC, area of triangle ADC is half AD. So we take half AD, CD, the sine of 45 degrees. That is the area. So the area of triangle ADC is half AD, CD, the sine of 45. So that now we're able to get the area of triangle ADC. Half. What is AD? AD is 30. CD is actually 13.49. The sine of 45 degrees, which is the area of triangle ABC. Using a calculator. Using a calculator, we have the following. So we have 0.5 times, right? 0.5 times 30. 0.5 times 30 times 13.49 times the sine of 45 degrees. Right, so the area, therefore, can be seen as exactly the following, which is 143.08, 143.08, 143.08. So the area of triangle ADC is 143.08 square meters. Square meters. So this gives us the area of the triangle ADC. All right, so yeah, that is the area. That is the area. That is the area. Any question so far, Pegelelo?
No
question.
questions.
All right, good. We move on. The next question is going to require you to participate. So, yeah, because it's very important that we're able to communicate, but also you can try a question or two during our lesson. Right, the following is a very interesting question. Right, so we have question 8. Figure 1 shows a ramp leading to the entrance of a building. Figure 1 shows a ramp leading to the entrance of a building. B, C, and D lie on the same horizontal plane. B, C, and D lie on the same horizontal plane. Right. The perpendicular height AC. AC is the perpendicular height of the ramp is 0.5 meters. 0.5 meters. And the angle of elevation from B to A. The angle of elevation from B to A is 15 degrees. The angle of elevation from B to A is 15 degrees. Right, the entrance of the building, AE, is 0.915 meters wide. Here's the entrance of the building, 0.915 meters wide. Calculate the length of AB. Calculate the length of AB. Right, so if we are to find the length of AB, right, for 2 marks, so we're going to work in the triangle. So we choose a triangle which to work. In triangle ABC, which means therefore, in triangle ABC, we want to find AB, which means now you're going to actually be in a position to have this triangle. So if you have the triangle like this here, this is C, this is A, and this is B. This is actually 15 degrees, and this angle is actually 90 degrees, and this side is 0.5 meters. The question you're asking is, what is the length of AB? What trigonometric ratio can we use here, Pehalelo? In the triangle A, B, C, we want to find AB. What trigonometric ratio? Can you use sine, cosine, or tan? Sine, cosine, or the tangent? So can we use SOR, CA, TOA? Which one?
I think sine.
Okay, that's a good point. Side. Well done. Opposite of hypotenuse. Opposite of hypotenuse. So you're going to use the sine. So you're going to then say the sine of 15 degrees is opposite. Opposite is 0.5. The hypotenuse is actually AB, like so. You're on point. Well done. And then now we actually obviously continue to find AB so that AB is the same as what? 0.5 divided by the sine of 15 degrees, which means that AB is 0.5 divided by the sine of 15 degrees. Let us use a calculator, right, to get the answer here. We use a calculator. So now then we're going to have exactly 0.5 divided by the sine of 15. And therefore the answer is 1.93. 1.93. So it's 1.93. Okay, let's write properly. All right, so we're going to write 1.93 units. Right, and the unit is the meter. So 1.93 meters. $1.93 So your AB is 1.93 meters. Figure 2 shows the top view of the ramp. Figure 2, which is this one, shows the top view of the ramp. The area of the top of the ramp is divided into 3 triangles. Right, as shown in the diagram. If BAE is 120 degrees, BAE is 120 degrees, and there it is. The size of this angle here is 120 degrees. Calculate the length of BE. Right, we need the length of BE. But we already know AB, 1.93 meters. So what is the length of BE in triangle? In triangle, ABE. Right, so in the end, then we want to find the length of BE there. And now, if you have a triangle like this where this is A, this is B, and that is E, 0.915 meters, 1.93 meters, 120 degrees, like so. So now, here we know two sides, two adjacent sides, and the included angle, and then we can use the cosine rule to find BE. So we then say BE squared. BE squared is equal to AB squared plus AE squared minus 2 AB AE cosine 120 degrees. What is AB? 1.93 squared. AE is 0.915. 2, AB is 1.93. AE is 0.915. Cosine 120 degrees, meaning B squared equals what? Let's use a calculator. Let's use our calculator. So we have actually 1.93 squared plus 0.915 squared minus 2 times 1.93 meters times 0.915 times cosine of 120 degrees, close bracket, equals, right, we're getting 6.33, okay? Because of the h here, it's going to actually increase the 2 by 1. So we're getting, therefore, 6.33 there, okay? So we write that one, 6.33. So here we have 6.33 there, meaning our BE, BE squared. If ever our BE squared is 6.33, you apply the square root, you apply the square root. Okay, let's continue. Right, so now you take the square root of 6.33. Let's take the square root. Let us take the square root. So this is going to become what? It's going to become the square root of 6.33. Right. So that square root is, the square root of 6.33 is 2.52. Right. So this is 2.52 meters. 2.52 meters. Right. 2.52 meters. So obviously in the 8.2, we're supposed to find the length of BE, and the length of BE is 2.52 meters. 2.52 meters. Any questions so far here? You have a question?
No, sir.
Okay, good.
No.
So, all right, good. So now we then have the fact that AB itself is 1.93 meters. The BE is actually 2.52 meters. 2.52 meters. Calculate right now the area of the triangle BFD. The area of the triangle BFD. So we have this triangle BFD. In other words, we have like this. This is our BFD. This angle here is 75 degrees, and we want to find actually the size of the area. Calculate the area of the triangle BFD. Right, so in other words, we need the area there. But what actually do we know? We know a couple of things. We know that this particular side is equal to also this side here. Right, because we know that BF is equal to FD. So we have BF is FD. And we have that BFD is 75 degrees. And we have that BF is equal to, here is a very important result. BF. What is BF? So the examiner told us that BF is equal to 5 out of 7. So BF is 5 out of 7 BE. Right. So in other words, if ever BF is 5 out of 7 BE, is 5 out of 7. What is BE? BE is 2.52. 2.52. Right. So if this is the case, then we can just use our calculator to just compute this one here. And see to it that we're able to get the answer. Let's check. So what we're getting here is the following. Right. Right. Okay, we continue. So what are we getting here? We're getting 5 out of 7 times 2.52. 5 out of 7 times 2.52. 1.8. So the BF is 1.8. 1.8 meters. So you can see that the BF is 1.8 meters, but also this one is also 1.8 meters. Right, so we have that this one is 1.8 meters, but that one is also 1.8 meters. So we need the area of BFD. Right, so you can find the area now. It's easy. So we then say area. Area of triangle BFD is actually equal to half. So it's going to be half BF DF, the sine of the angle included, which is 75 degrees. So this is 1/2. What is BF? It's 1.8. And the DF is also 1.8. The sine of 75 degrees, which is the area of triangle BFD. Area of triangle BFD is this. Right, so what is it? So this is then the same as 0.5, because the 1/2 is the same as 0.5. We multiply it by 1.8. We multiply it by 1.8. We multiply it by the sine of 75. And this is 1.56. 1.56. 1.56. Right, because now everything is measured in the length of sides are measured in meters. So it's 1.56 square meters. 1.56 square meters. 1.56 square meters. Right. 1.56 square meters. 1.56 square meters. 1.56 square meters. So we continue. We continue. Right, we move forward. Any questions so far, Pehalelo?
No, sir.
Okay, good. We move forward. Okay, the following is a very, very interesting one. This one, I would be interested in seeing your participation. In the diagram below, T is a hook. Here it's T, and T is a hook on the ceiling of an art gallery. So now, let's continue and look at what we can do. Right, so this, in the diagram below, T is a hook on the ceiling of an art gallery. Points Q, S, and R. Q, S, and R are on the same horizontal plane. So Q, S, and R are on the same horizontal plane. From where three people are observing the hook, T, the angle of elevation from Q to T is X. From Q to T is X. QSR is 90 degrees plus X. QSR is 90 degrees plus X. QRS is X. QRS is X. QR is 5 units. TS is SQ. TS is SQ. So this TS is equal to SQ in length. Right. Prove that QS is 5 the tangent of X. Prove that QS is 5 the tangent of X. What rule can we use here, Perhalelo?
Sir?
What do you think? Because here in 8.1, we need to prove that QS is 5 10X. So to prove that QS is 5 10X, how do we prove this? So what rule can we use to prove this result here?
Let me see.
Okay, so you think about it. You think
Mhm.
about it because we're here and we're not in a hurry. So think about it. I'm giving you 3 minutes. I'm not rushing you. I'm giving you 3 minutes. And in the 3 minutes, think about it. In the 3 minutes, think about it. In the 3 minutes, think about it and let me know. If you can't see, talk to me, please. Right.
Yeah, I can't see it, sir.
You can't see.
Mm-hmm.
Okay. Right. You see the bottom triangle, the gray one, the shaded one is 90 degrees plus X. S, Q, R, X. Like that. So this is the gray triangle that is X. And this angle is like 90 degrees plus X. What do you think? I'm giving you time because what are we supposed to prove? We need to prove this one. 8.1. QS is 510X. QS. QS is 510X. So how to prove this? How do we prove this? Right. Right. So we continue.
Okay, I'm not sure, sir.
Okay, that's fine. Never mind. I'm just testing you. I always tease you. And from time to time, I will ask you to participate and give these questions some thought and you think about it. But now, the only thing you're supposed to look at here is the fact that you need to deal with QS. QS can be seen as the side of the upper triangle, but also it can be seen as the side of the triangle QSR. QSR. And now there's a 5 here and there's a 5 there in the result. So there's a 5 in the answer, but there's a 5 in the side of the triangle QR, meaning that, hang on, we can really see that, okay, Mr. Examiner, your answer has 5 in it, but 5 came from here. It must have come from somewhere. Very likely it came from this side here, the length of QR. So, and this answer has no square roots. If the answer is square roots, then it means we use the cosine rule. But if the answer has no square roots, it means that we used the what? The sine rule. So the examiner must have used the sine rule here. So we're going to work in this triangle here that is very nice and easy. So you're going to work in triangle, in the shaded one. Triangle, right, in triangle QSR. Triangle QSR. So you have QF. QS over sine X. QS over sine X. QS over sine X is 5 over the sine of 90 degrees plus X. Sine X divided by the sine of 90 degrees plus X. 5 sine X. 90 degrees plus X is what? In which quadrant is that? That is in the second quadrant, which the sign is what? Positive. But there is a cofunction change by the Coco rule. Right, the Coco rule is clear when you look at the cast diagram. 0 degrees, 90 degrees, 180 degrees, 170 degrees, 360 degrees. So that when you say 90 degrees plus, you are making 90 degrees larger towards 180, and 90 degrees plus is in the second quadrant, which the sign is positive. But there's a cofunction change to the cosine of x. But what is sine x over cosine x? It's 10x. So that indeed we've been able to prove that QS is 5 10x by using the sine rule. By using the sine rule. By using the sine rule. Right. So think about this. Think about this. We move on to the next thing. The next one is 8.2. Prove that the length of QT. The length of QT is 10 sine x. QT. QT. What is the length of QT? It's 10 sine x. So I want to prove that the length of QT is 10 sine x. This QT is 10 sine x. How can you prove this? Right, so we continue. Right, so we continue. We continue. We continue. How to prove this one, Khalil? What do you think? I always give you a chance. I must be fair. I must give you a chance because you are the student. If I never give the student a chance, that would be a big mistake because I've learned this, but I must give you a chance. You try, and we see how well you can do, and then we can be able to appreciate your contribution. And this is what really drives us. But now we must give you a chance because if you don't give you a chance, you're making the biggest mistake in our lives. You're making the biggest mistake in our lives. Right. We're making the biggest mistake in our lives. I'm giving you a chance to try 8.2. QT is 10 sine x. But look, we have the base triangle that is sort of at ground level. Q is this one. S and R. This angle is 90 degrees plus x. This one is x. Okay. We want to prove that the length of QT is 10 sine x. QT is 10 sine x. Right, so what exactly can we do here? The angle of elevation from Q to T. From Q to T is x, meaning this angle here is x. So what rule do we use to find the length of QT? What rule can we use here?
I think the sine rule.
Hold on, because it has the answer has no square roots. So we're going to use the sine rule because now we need to find the length of QT. We're going to work in a triangle that has the QT as a side. But also a triangle that has like a lot of information because this QT is the side of many triangles. Like QT is the side of this triangle here, but also QT is the side of this triangle, the waved one. So even the waved triangle also has QT as a side, or as its side. So yeah, we're good. But yeah, let us continue. X here, this one is also what? It's also X. So that in the end, therefore, you can be able to find this angle here. And this angle here is 180 degrees minus 2x because this is x and x. Because this side is equal to this one, it means this angle is equal to this. Because in a triangle that is called isosceles, Right, there's a triangle that is called isosceles. Isosceles triangle. Isosceles triangle means that you have two adjacent sides equal, but also the base angles become equal to each other. Right, so we're good. So that in the end, okay, so that in the end, we want to find a QT. QT. So we're going to work in the triangle. Right, we're going to work in the triangle QTS. In triangle QTS. With QT over. Right, in the triangle QTS, you'd have QT over. QT over the sine of the angle opposite. And this is 180 degrees minus 2x, which equals, that is QT over the sine of 180 degrees minus 2x is equal to what? Is equal to, you can take one of the sides, for example. Right, so we can then say that if the sides are then equal to each other, if you take QT over the sine of 180 degrees minus 2x, it is actually equal to another side. Right, what other side exists? Check the triangle. QTS. Okay, if these are equal, then these are also equal to each other. So that in the end, then if you have QT over the sine of 180 degrees minus 2x, then you'd have, for example, a TS, or you can say QS, which is clever. Doesn't really matter which one you take because QS and TS are equal to each other. They're equal to each other. So you can take like QS. QS over the sine of the angle opposite QS, which is X. So that we have QT is QS, the sine of 180 degrees minus 2x, which is actually divided by sine x, which is QS times, in which quadrant is 180 minus? 180 minus, it's in the second quadrant where the sign is positive. By the cast rule, 0, 90, 180, 270, 360. So 180 minus 2x is in the second quadrant where the sign is positive. So it's going to be actually the sine of 2x. Okay, so yeah, this one is going to be the sine of 2x. It's going to be exactly the sine of 2x. And it is divided by the sine of x. Check, let's check. Take a look at this and see what we're getting. QT. Right. Is what we want. QS, we already know. What is QS? It's 5 10x. So in the place of QS, we put 5 10x. Sine 2x. Sine x. What is the sine of 2x? 2 sine x cosine x divided by sine x, which is equal to sine cancels, giving us 5 10x to cosine x. What is 10x? 10x is sine x over cosine x to cosine x. And therefore, the cosine cancels out. 5 by 2 is 10 sine x. So that qt is 10 sine x. Qt becomes exactly 10 sine x. Qt is 10 sine x, which is exactly what had to be shown here. Think about it. Okay, we're going to ask you, okay, look, sine 2x. Sine 2x is 2 sine x cosine x. This is called the double angle formula. Double angle. Double angle formula. Double angle formula. So any question? We have a question. In the absence of a question, we move forward. In the absence of a question, we move on. Right. In the absence of a question, we move on. Think about these things there and make sure you understand these things. Make sure you can interpret these things. There are going to be more problems even tomorrow. We're going deeper. Even tomorrow, going deeper in analyzing these kinds of questions. So we need to build the skill. We need to build the knowledge base, and that is the strategy. And that becomes the strategy. Right, and that becomes the strategy. And we welcome right now. Okay, I was thinking that student there is. Right, so there's another student that is joining. Wanele. Wanele Andiswa. How are you, Wanele? Right, so we note A and B, or 8.1, 8.2. Calculate the area of triangle TQR. TQR. Find the area of triangle TQR. If TQR is 70 degrees, TQR, the angle TQR is 70 degrees. X is X is 25 degrees. This one. So you need to find the area of triangle TQR. Right, sir. With this one, you already know it's 5, but we know QT. What is QT, for instance? We know that QT is 10 sine X. 10 the sine of X, X is 25 degrees. That is QT. So to find the area of triangle TQR, area of triangle TQR, right, the area of triangle TQR is half the product of the adjacent sides multiplied by the included angle. Adjacent sides are QT. QR, the sine of 70. Area of triangle TQR, QT. QT is 10 sine X. QR is 5. Okay, you can put a 5 here. Sine 70, the area of triangle TQR. Tan the sine of x, 70. Which is area. Right, so zero 0.5 times 10. So we have here 0 0.5 times 10 times the sine of, okay, check, check, check. Okay, this is 10 sine x because the QT is 10 sine x, but x is 25 degrees. So you need to put 25 degrees there. X is 25 degrees, but obviously you have the sine of 70, which is that. But the, yeah, sine 70. So you're going to use a calculator here. Zero 0.5 times 10 times the sine of 25. So 0 0.5 times 10 times the sine of 25 times 5 times the sine of 70. So that we have 9.93. 9.93 square units. 9.93 square units. 9.93 square units. So the area of triangle TQR is actually that one. So to find the area of triangle TQR, we use the trigonometric area formula we saw. What does the area formula say? It says that if you have a triangle like this, A, B, and C, A, B, and C, area triangle. ABC is half. Half AC the sine. Okay, half AC the sine of B. Yeah, half AC the sine of B. Half AC the sine of B. Half AC the sine of B. So in other words, the area of a triangle, if you say half AC the sine of B, but yeah, there are different versions of it. You know, you can say it many ways. Like you can say, okay, half AC sine B, or you can say half AB sine C, half BC sine A. So now it's half AB sine C, so half the product of adjacent sides times the sine of the included angle. Or you can say half AC sine B. So in this case, to find the area of triangle TQR, we say half, this angle is 70, half QT, QR, sine of the included angle 70. So QT is 10 sine X. QR is 5 sine 70. So this is what we're getting. This is what we're getting. So any question?
No, sir.
No question. Right, so we move forward. We move forward. Question 7 is very interesting. So here we're just talking about the 3 rules today: the area rule, the cosine rule, and the sine rule. Or the sine rule, the cosine rule, and the area rule. Those are the 3 rules we're talking about. In other words, we're talking about the sine rule, cosine, the area. Okay, let's continue right now with these rules and see what we can do. So this one is yours. 7.1 is yours. But let's see what we can do. First, we read through the question and we make sense of the question. And we sort of examine the extent to which, this question can be attempted. So we're saying points B, C, and E, lie in the same horizontal plane. B, C, and E lie in the same horizontal plane. A, B, C, D is a rectangular piece of board. A, B, C, D is a rectangular piece of board. C, D is a triangular piece of board. CD is a triangular piece of board having a right angle at C. Each piece of board is placed perpendicular to the horizontal plane joined along DC, as shown in the diagram. The angle of elevation from E to D is X. From E to D is X. BEC is 2X. BEC is 2X. Oh, rather, yeah. BEC. BEC is 2X. And the angle EBC is 30 degrees. There's an angle 30 degrees here, which is the angle EBC, 30 degrees. Show that DC is equal to BC over 4 cosine squared X. Show that DC is equal to BC over 4 cosine squared X. Let's look at these here. Let's look at these here. Right, so I want to show that DC is this. How do you show that DC is exactly this? For 6 marks. For 6 marks. We want to show that DC can be written as BC. So you can see that there is D here, the C, but there's also a BC that is going to come out of this. Right.
We're going to use the rule.
Come again?
Are we going to use the area rule?
Okay, that's a very interesting one. I'm going to use the area rule. Right, so you really are on point. Right, you really are on point. Are you going to use the area rule? So obviously you need to look at these questions and think, but think very carefully. You need to look at these and realize that the answer has a BC in it. So if the answer is a BC, but it also has a DC, so the BC can be obtained from this because now it has a square, but is the area given here in the story, we did not come across the area. So in other words, you can use the sine rule. You can use the what? The sine rule. Check it out. We can then actually proceed to use the sine rule. We can use the sine rule. So now we continue. Okay. We can decide to work in this triangle here. Right, working in this triangle, we can be in a position to get what we want. We can be in a position to get, for example, the BC. And then now, if we have the BC, then we can be able to get, for instance, this particular side here. Right, so we can then say in triangle. We can decide to work in the bay in the triangle at the bottom, in triangle BCE. Right, so we want the BC to appear. Right, so we can then say BC. Right, so we can say BC over BC over the sine of 2x. BC over the sine of 2x is CE over the sine of 30 by the sine rule. By the sine rule. So if you then say BC over the sine of 2x is equal to CE over the sine of 30. So that in the end, then we can actually be in a position to find the CE. Right, so if you make CE the subject to cross multiply, so CE is going to be exactly BC sine 30 divided by the sine of 2x. The sine of 2x. So that we have BC, the sine of 30 is 1/2 divided by sine 2x is 2 sine x cosine x. And if you simplify this 1/2 and that, it's going to be actually BC over 4 sine x cosine x. So this will be CE, but CE is not what we want. What we want in this question is DC. So we want DC, so we can then say, Mr. Examiner, we're going to work in triangle. We're going to work in triangle DCE. Meaning in the triangle here, DCE, want to find DC, but there's a CE, so to do with the opposite over adjacent, which means that you're going to deal with the tangents using SOHCAHTOA. Right, using SOHCAHTOA. Right, using SOHCAHTOA, then we get the following. We get actually the following. Okay, so in triangle DCE, we can use opposite over adjacent. So we have the tan of x, which is opposite DC over the adjacent CE. We want DC. So which means that DC is CE tan x. What is CE? You can put this one. CE is BC over 4 sine x. 4 sine x. And then you have the sine x, the 10x, which is sine x over cosine x. Upon careful examination, the sine cancels out, and then we are left with BC over, there's a 4. So we have cosine, which is actually cosine squared x. So we actually have been able to establish, therefore, that DC is actually BC over 4 cosine squared x. Any question on this one? Any question on this one? Any question on this one? Any question on this one?
No, sir.
No question. Right, so we move to 7.2. We move to 7.2. Right, we move to 7.2. We move to 7.2. Right, so moving to 7.2, we have the following. We have the following. Right. Yeah, any question? Okay, your take on the next one. Your take on a right. Right. We continue. Right. So what is actually your question here so far? You have no question. So, right. Now, 7.2, show that the area of ABCD is 3AB squared. So the area of ABCD, the area of ABCD. What is ABCD? It's a rectangle. It's a rectangle. So this ABCD is a rectangular piece of it's a rectangular piece of board. But need to show that its area is 3AB squared. ABCD. So how do you find the area of ABCD? How do you find the area of that one? Obviously, there are a couple of ways to do that because you already know the DC. You already know DC. And the area of ABCD is actually like length by breadth. So it's going to be BC times DC. Right. So in other words, we come here as we conclude our lesson now. We come here and we then say if you are supposed to find the area of the shape rectangular piece of board ABCD is the length multiplied by the breadth or multiplied by the width. So what is the length? Well, you can take BC as the length. What is the width? You can take DC. So, but also you can take the fact that if you take the BC times DC, but you see DC is equal to AB. So you can take that into account because these are opposite sides of a rectangle, so they're equal to each other. So now at this point, you then say BC. And then you multiply by DC. DC is BC over 4 cosine squared x. Okay, so now let's simplify these together. So which means, therefore, at this point, you would have, therefore, that in the place of DC, you can put this one. Right, in which case, if you put this, then it means that you'd have BC, which is BC squared divided by 4 cosine squared x. But how is BC related to AB? How is BC related to AB? So obviously you know that the area, because you must actually show that it is 3AB squared. 3AB squared. So to show that it is 3AB squared, which is the area of ABCD, you need to recall that the area, you need to recall that DC is AB. DC equals AB. So that now the area of ABCD, right, the area of ABCD, which is rectangle, is length by breadth, we've already seen. So we can actually say, for instance, this is AB times BC, like that. AB times BC in that particular manner. So the question would be, what would BC be in this particular equation? Look at this. There is this particular equation we have got, and we wish, for instance, to transform this particular equation, but x is 30. Okay, remember x is 30, so you already got the answer. X equals 30. So which means that to get BC, that we need to put here, we can cross multiply. So in other words, if ever we then say DC is BC over 4 cosine squared x, so that now we need to get BC. BC is 4DC cosine squared x. Okay, that is AB. So in the place of BC, you put 4 DC cosine squared x. You have AB 4. What is DC? DC is AB. What is x? 30 degrees. 4. This 4. AB times AB is AB squared. Right, so we have this. What is cosine 30 degrees? Now you remember the special triangles. This one is 30 degrees, square root of 3, 2, 1, 90 degrees, 60 degrees. So cosine 30, SOHCAHTOA. SOHCAHTOA. So that the cosine of 30 degrees becomes exactly what? The cosine of 30 becomes exactly the adjacent over the The hypotenuse is 30, adjacent square root of 3, hypotenuse 2 all squared. 4. AB squared. If you square this, becomes 3 out of 4. 4 cancels, 3AB squared. Area. We've already got the answer. We've already got the answer. Now check it out. Check it out. In other words, we have the area required. Area of ABCD. What is this area? This area is actually equal to 3AB squared. 3AB squared. 3AB squared. Any question on this one, Pehalelo? Do you have any question on this one, Pehalelo?
Not really.
I could imagine. Right, here's another question. This one I'm giving to you as your homework because
Okay, sir.
our time has elapsed. I'm giving you question 7. I'm going to read through the question because this is going to be at the end of the recording. So you're going to have an opportunity to try this question on your own and see how far you go. Question 7. A landscape artist plans to plant flowers. Remember, this one is a landscape artist that is planning to plant flowers within 2 concentric circles. So this person wants to plant flowers within 2 concentric circles. Concentric circles are circles with the same center, but essentially different radii. Around a vertical light, here's a vertical light there. Pole PQ. PQ is a vertical light. R is a point on the inner circle. Here's R, a point on the inner circle, and S is a point on the outer circle. There's S, a point on the outer circle. R, Q, and S lie in the same horizontal plane. So we have R, Q, and S lie in the same horizontal plane. RS is a pipe used for the irrigation system in the garden. RS is a pipe used for the irrigation system. The radius of the inner circle is R units. Right, so we have the radius of the inner circle. Here's the inner circle. Therefore, this is R units, which is the distance from the center of the smaller circle, or what you call the inner circle, to its circumference. Right, and we can see that that is the radius of the inner circle is R units, and the radius of the outer circle is QS. QS. QS is the radius of the outer circle. The angle of elevation from S to P is 30. S to P is 30. RQS angle. RQS is 2x. Right, we can see the 2x. 2x is this one. Angle RQS is 2x. Okay, this one is your homework. So this one is SUA's work, is your home activity. I'm going to check it tomorrow because I'm going to be right back tomorrow to discuss more of this. Like I have like tons of the questions here. This is just a hint of the questions that exist, but all these are past examination questions on the 3 rules. On the 3 rules, the area, the cosine, the sine. RQS is 2x. Angle, RQS is 2x. 2x, you can see. PQ is square root of 3r. Show that QS is 3r. Okay, that is 7.1. 7.2, determine in terms of R the area of the flower garden. Okay, we're not doing it now. I'm just giving it a homework. I'm just reading through so that even when at the end of the video, because I'm going to send you the recording during the course of the night, you can be able to see the question and you can move the video, like you can fast forward the video to the end to just see how well you can be in a position to try everything. So yeah, that is something very important here. So yeah, determine in terms of R the area of the flower garden. Remember this the flower garden, these flowers that will be planted within 2 concentric circles. So you have obviously in terms of R, the area of the flower garden. Show that RS is this one. You need to show that RS, the distance there, is this one in with the square root. And we said that, and I mentioned this, and I'm mentioning this. This question is a question I pretty much did last year. It's a past exam question with the students I was discussing with. But I must indicate because the question is a square root. It suggests cosine rule. Square root suggests cosine rule in 7.3. So if I try later to see what rule to use. Now, 7.4, if RS is 10 meters and X is 56 degrees, calculate RS. Calculate, oh, okay. So they've given you the R, they've given you the X, and they need RS in the just 2 marks to perform some substitution there. So that is exactly what we have. Right. So we're good. We are most certainly so good. We are most certainly so good. Right, so yeah, take a chance and look at this question and try it, please. It's a past exam question. And now I mean there are lots of questions we're gonna like attempt in this area, but obviously in our discussion tomorrow we shall look at other topics as well. It cannot help to only know this topic and not know other topics. So right, there are other topics for this term that we will discuss. So it's something very important that we need to learn. Right, but any question for now? Pekalelo, do you have a question?
No, sir, I don't.
Right, so, right, thank you for obviously joining us today. It was awesome having this discussion, and your homework, your home activity is actually there for you to try. A past exam question, and we shall have a fair chance to obviously discuss the corrections tomorrow to this home activity. Right. Otherwise, then I'm sure that until tomorrow, take care and enjoy yourself and have a good evening. Okay.
Bye bye, sir.
Okay. Thanks. Pahalelo and goodbye.